Hello, this is W60L, and I want to show you a radio that we're going to repair today, the Kenwood TM-V71. If I turn it on, you can see the problem pretty quickly. Yeah, it's this screen. When I turn the knobs, you get some reaction over here, but it doesn't read out properly. I took the radio apart and I found that there's two display chips. One drives this display and one drives this display. And I compared the input signals, the clock, and the outputs, and I determined the chip on this side is probably bad. So what we're going to do is take this thing apart and replace the chip. And along the way, we'll journey into the world of surface mount soldering. In particular, soldering very small chips that could be quite difficult to do. This is one of them. I'm not used to this kind of soldering, so this will be very adventurous. Stay tuned. All right, so here we slid off the panel from the front. And if we just unclip this, we can get to just that. And to take it apart, I think it's just two screws. I think that's it. Let's see. Yep, there it goes. So now you can see what we have to do. And it's one of these two chips we have to replace, and I can't remember which one it is. So let's power it back on and remind ourselves which one it was before we pull out the wrong one, which would be really bad. It's that knob side one that needs replacement. So that's what we'll do. We'll replace that one. Okie doke. All right, take this off. So the knob side replacement one is this one right here. All right, I'm gonna mark this chip over here with an X, just so we know which one to take out. Now, I looked for this chip online, and my first instincts, for some reason, were eBay. I found one on eBay, about $10, but it didn't have the logo on it. Emailed the seller, they said they forgot to put the logo on it, and they sent me another picture of it with the logo in it. So I didn't get that one. It turns out you can still get this part from JVC Kenwood. I ordered two. They were $9 and some cents each, plus $6 shipping and handling. Took 2 weeks, and now I have the chip that's going to go in here. Now, because I'm not really used to this kind of work, I just haven't done a whole lot of chips with this many legs or surface mount. I got a bunch of surplus boards here from my collection, and I just started removing all the quad pack chips. Well, not all of them, but most of them. And I learned a lot of things while I was doing it. I also watched several hours of YouTube tutorials on how to desolder these kind of chips. The first interesting thing was flux. A lot of people used flux during the desoldering. And I found out through experimentation that when you have flux down on here for desoldering, the flux can get kind of sticky and make the chip tend to stick to the board, and then it's harder to lift it off. Second thing I learned was if you're too aggressive with pulling the chip off like you're in a hurry, you can easily rip the pads right off the circuit board. Let me show you one where that happened. If you look right here, really carefully, you can see that I pulled this up a little too fast. And these tiny little pads, they're quite small. They just ripped right off the board with some of the traces with them. So you really have to wait until you're absolutely sure every side is liquidus before you attempt to pull it a little bit. The other thing I did is I bought a new piece of equipment. This is a heat gun where you can adjust the airflow and the temperature with these controls on the front. And what I found is, first of all, I had to look for a nozzle like this. This nozzle actually has flutes for each side of the chip, and that's really important because you don't want to blow hot air all over the board, unless you're scrapping the board, of course. I had to mess with the temperature a lot, and it turned out that the temperature you want really isn't the solder melt temperature, because the temperature it's being regulated is in the tip of the gun right here. And that's not the same as the temperature of the air that hits the component. So you really have to shoot for a higher temperature in order to get the part off quickly, which you do want to do. The other thing I found was that the airspeed was an interesting parameter. You can desolder with low speed air, however it takes a lot longer. And in this case, I really want to be quick about it so I don't lose any components on the board with it. If the air is really fast and you're not careful, you can blow small components off the board. Little tiny capacitors and stuff will just blow right off with what you're doing. So you need to aim very carefully if you use high-speed air. But I still think using the high-speed air is the right choice to make here. So for this next part, I'm going to desolder the chip, and I'm going to really focus on a good position for me doing the work rather than the camera angle. So The angle may not be ideal, but at least you'll be able to see the process. First, I'm going to take off this little flex print cable here so I can maneuver the equipment easier. Let's see. There it goes. So it's just like a little flap, and it's moved up now. You can pull this out. Now this part we can put away. If we lose it, we're in trouble. By the way, the only signals on this, there's 5 volts ground, and there's transmit data and receive data. Very simple. And someone has reverse engineered some of the commands. It's available on GitHub. Okay, so I'm going to get the board just stabilized so it's not moving during this. By the way these tips work on the heat gun, it's kind of interesting. I have the wrong size on here, so let me take this off real quick. There's holes inside it, and the air kind of goes around in a turbulent way into this plate right here, and then eventually reflects and goes out these slits. So the air is a bit cooler once it goes through this assembly compared with some of the other ones like this one, where it just goes straight through. I thought that was kind of interesting. So here's the one that fits this chip, and just to demonstrate that real quick, fits right over the chip, so it should be pretty good. So yeah, I put this on here like that. I just bought these on Amazon. They were some of the cheapest ones I could find. They weren't intended to be the fanciest or best at all. There we go. That'll be good. I'm going to set the heat gun at 770 degrees for this work. I have 2 tools here I'll be using. They came with the heat gun, but they're just basic pliers. I mean, tweezers, nothing special here. All right, Eugene, you got it? Recording? Yeah. I've got to really watch out for these parts over here. These are 0402 resistors. They're pretty much the smallest any normal person would ever want to deal with. And maybe because of that, I'll turn the fan down a little bit. I'm watching the solder to see when it goes liquidous. That's a technical term for liquid. I can see some of it is right now. There it is. Right there, just like that. Clean as can be. Okay, so there's a little bit closer shot of the pads. And you can see, you know, our next job here is going to be to clean these pads very carefully. We'll start with some alcohol to take off any flux that might be there from the factory. Then we'll use solder braid carefully going in the direction of the pads and traces so that we don't apply pressure the wrong way. Get some flux off. It really is the best kind of thing to use for this. And the goal here is not just to get it wet. We actually want to remove some of the flux. So we go very gently here, and then we switch Q-tips with each side. You can feel a lot of traction on there, which I don't like. Some texture, so that means we're definitely going to have some work to do with the solder. So I'll be very gentle here. There we go. All right. Didn't get much of anything off there, but that's all right. Now we need to inspect the solder a little bit. Let's see if I can get in closer. All right, there we go. So we need to check the solder and basically clean it up quite a bit. And the way we're going to do this is basically to drag a solder wick over it very gently with a soldering iron on top and a little bit of solder to help out. If you hear some strange sounds, it's just my kids fooling around in the background. So let's just take this first area right here. See how it goes. There we go, just like that. See that? I cut this off and do it again. Probably use a lot of solder braid for this, but I bought extra, anticipating that I'd need a lot. That looks pretty good, except that little spot right at the end there. It's getting pretty windy. There we go. That's one side done. After this, of course, we got to clean off all the flux that's caused by this process. You never want to reheat flux into your solder joints, especially old flux. The more times it gets reheated, the nastier it is. You just really don't want that inside air. I have to make sure I go in the same direction as the traces in the pad, so I can't, drag it sideways. I have to go directly with the same way, or else I can impart force on the joint, and that's not good. A little bit of solder on the tip is just for the conduction of heat. Zoom out a little bit. Maybe you can see better what's going on. Really nice there. Very smooth. All right, now these other two sides will be a little trickier. Let's see what we can do about that. That one and that one, huh? I'm usually very stingy about the solder wick, but I think in this case, I just have to really use as much as I need to. I've now successfully melted the chassis. That's that smoke you see over here. Yay. Oh well. The plastic chassis is not what makes this radio work or not. It's the rest of it. As you see, there's some components over here, so we don't want to mess that up. All right, zoom out a bit. Put solder on here, again for the sake of conduction. And I guess we'll just take it, a few pads at a time. One of them looks a little bumpy. I gotta be careful with that one. Hope it's not coming up. So there you can see the results. It's not clean yet, and that's what we're gonna do next. Got my flex off here, and we're gonna clean it up real good. Remember folks, if it doesn't have a lot of these little symbols on it, it's no good. And this time, oh yeah, I feel a lot less texture. Before, it was kind of pooling in some spots on the cloth. This time it's just real clean. Here's how that Q-tip looks. You can see there's a little bit of dirty stuff on it. It means it's working. Slowly rotating the Q-tip as I go, because you really don't want to spread this used sticky flux on anything. You just want to get it out. Look at that, nice and clean. Get a new Q-tip. on and then brush it. How's that? I think that looks really good. And I don't know if you can tell, but that last area that I haven't done yet, you can see it looks dirtier. Whew. Can't quite zoom in enough. But yeah, a little bit dirtier looking there. So let's dab it. Then slowly brush it off. I can see little bits of solder that are stuck on here still that are like bumps. And I could go back and clean them off. I don't know. What I don't want to do is put too much heat and work into these pads because they just won't last. They'll start popping off. So I think we're good here. I'm going to do one more sweep around it. Just in case some solder goes beyond where we expect. At least it'll be clean there. You could argue I'm spreading it around right now, but I think I've got most of it off. This is just a little bit extra I might get. The Q-tip looks pretty clean, so probably there wasn't a whole lot extra. Okay. Now I'll do an inspection close up, and if it looks good, we'll put flux on it and move on. To help me practice, I've got this TV board here from an older television or something, and it has a similar pad here. I'm going to put the old chip with the X on it onto this pad. Let's see if we can do that. For the flux today, we're going to use this stuff from MG Chemicals. It has the correct symbols on it, so you know it's going to work really well, right? If it says that, it's probably pretty good. The steps I'm going to try to follow, I've already cleaned this up. I'm going to lay the flux down on the board first. This flux is really thick. It's like Vaseline, kind of. It's hard to get it to squeeze out, but I think it's going to be okay. All right. So over here, I'm not going to worry about the chip's orientation. I'm just practicing the soldering act. So there it goes, plop. Let's see if we can get it to where we need. Kind of interesting, the flux is sort of holding the chip in place because it's so enormous. I mean, it's so thick, you know. But the question will be if it's in the right spot. It looks like it is to me. The drag solder technique is really attractive to me, but I don't have any experience doing it. Let's just put a little bit on the corners so the chip doesn't move. All right. I'll try this side here. I get a reasonable sized blob on the soldering tip and go slowly across it like that. There it is. Let's do that again. Let's try this side over here. Okay. Now let's try this one over here. And lastly, this one over here. Okay, now we have to inspect it for solder bridges and clean it off. So looking at it up close did reveal several spots that are probably bridged. So we'll see if we can take care of those. This is good practice for when it's in the radio. Much easier to get to here on this board. First was over here, a little corner where two got hit at the same time. They're right next to each other. I wonder if I can just do like that. Nope, not quite. Okay. We'll use the braid. There. That's gone. That's good. All right, we got one over here in the middle. All these bridges are kind of not at the pads, but rather on the legs. Kind of interesting how that worked out. Just gonna rotate it. Come on, there we go. That's off. Looks like it could use a dot of solder right there. There. Okay. I think that chip would work if that circuit board was designed for it anyway, which it isn't, of course. The next steps would be to clean all this off with alcohol and, of course, flux off, and then inspect it. I don't see a reason to practice those steps on this board, so let's switch boards. Okay, we've got the part taken off, we've got it all cleaned up, and now it's time to put the new one on. Here's the new chip. Put it in this little bag. Blue ESD bags are not dissipative, but they also don't cause harm. That's what that is. So it's not going to do any harm to anything, but it also isn't going to help you out any with dissipating. So it's fine to put there. There's that. I bought 2 chips, just in case. Now, for the orientation of the chip, we want to match the other one, and that's seemingly dictated by this dot here. There's a little dot on the circuit board right there, and there's also one over here, so we just want to do it the same way. The dot on the chip lines up with the dot on the board. I really wish I had like a stick glued to the top of it or something. There it is. Let's straighten it out a little bit. Actually looks pretty good right now. So I'm going to go ahead and put a little bit of solder on the corners. Just 2 corners, tack it down, and then I can do the drag. This corner is very accessible, so let's do that one first. Pushed it a little bit there, but I think it's not any worse than it was, alignment wise. Let me look at it very carefully and see. Okay, the alignment looks really good. I checked under this little 30x magnifier that somehow lasted many years. I used my inspection light, and I like to use red for that. Red seems to show pretty good what's going on. And it looks good. So, now the challenge is to drag over the rest of the joints. We've got 2 that are in really good. I also have to decide how much flux to put back since I removed some of it for the work. This is tricky because I can't really get a good angle like I want. But I think this will work right here. Let's try. Well, kind of got it. Let's go for the next one. All right, definitely saw some bridges there, but it's nothing we can't remove later. Looks good. And lastly, the troubled side with all the itty bitty parts around it. See what happens here. Okay. There it is. Now we just have to go in there and clean it up a little bit. And should be okay. I think that one got cleaned up just now. I'm going to check the rest of that chip off camera and see how it looks. We got a couple more here to do. Right between these 2 parts. I think I can see it from here actually. I bet that did not help. Okay, I inspected it, fixed all the joints, and I think it's good to go. The soldering is a little anemic in some places, but I feel like if I go in to fix it, I'll just make the problem worse. So I think it's time to power it on carefully and see what happens. One approach would be to supply the 5 volts and just verify you don't have any shorts, but I don't think I have time for that. I do have time for it, but I don't want to do it, is a more accurate answer there. So, we'll see what it does, and we'll just turn it off right away if it does anything weird. Do it like that, kind of. All right, voltage, please. Nothing. Interesting thing is we've got nothing on there. No foreign languages this time. So let's look for for shorts again. I'm going to try reheating this. Maybe I can line it up a little better this time. Okay, it's liquid now. All right, let's plug this back in. I think this time we'll see something, whereas before we didn't. Okay, it's plugged in. Here goes. It says hello, and we got nothing. Well, I finally got it installed properly. Here it is. It took a long time. Many mistakes were made. I had to resolder it. I lost one tiny little part, which was so small that when it popped off the board, I never saw it again. I had to order a part to fit in there. It's an 82K resistor. Once I did that, I had to search around here, and basically I expect around 16, 17, 18 mega ohms on each one of these points. And the ones that were open circuit or shorted read differently, of course, so I had to go down here and fix them. And my microscope broke, and just all kinds of things happened. This is not the kind of soldering I want to regularly do. It's just not my style, and I hope I never have to do it again. But there it is. It's all in there. It's kind of ugly. I don't know. Let me show you how it works. I'm going to install it real quick and then turn it on. You can see it. And I found you can turn it on and test the screen. So let's do that. We just hold down the function. There's the screen. You can see all the parts are illuminated properly. And yeah, it seems to look pretty good. So I call that a success, but I don't think I'll ever do one like that again. It was just a little too stressful and very difficult and time consuming. Maybe worth it, but I don't know. Not my style.